This is STEM Algebra 2 mini lesson on arc length, and we're going to go ahead and work example 2 in this video. So I gave you a good rundown on example 1. If you didn't watch that, go back and watch it. So I'm going to do this one quickly. We are finding this large arc measure or arc length, and we're going to use the same proportional statement, the central angle, and it's okay if it's over 90. It's okay if it's over 180 degrees. Whatever the degrees of the central angle is, 165. We're going to write a ratio comparing the 165 degrees of the angle to the 360 degrees in a circle. And we're going to set that equal to or in proportion to the ratio of the arc length to the entire length or the arc of the whole circle, which is the circumference, 2 times pi times the radius. Now my radius is 12 kilometers, and I know 2 times the radius, 2 times 12 is 24. So the circumference of that circle is 24 pi. Smaller angle to the whole should equal the smaller arc to the whole. All right, so then we're going to cross multiply. Again, it's always 360L, and I'm sure you're starting to see a pattern by now. We'll have 360 on this side. I've got to do 24 pi times 165. And again, I'm using my calculator to do 165 times 24, which is 3,960 pi. And then your last step is to solve for L. So divide both sides by 360. And this one's a nice, even, no decimals. 11, well, there are decimals because of the pi, but we've got 11 times pi. Now, again, this is an arc length. I don't want to forget units. They're kilometers. And for the exact decimal answer, I'm going to take 11 times pi, not times 3.14, 11 times using the pi button on my calculator. I get 34. And the answer is 34.5575 kilometers. But for this unit, we're going to go ahead and round to the nearest tenth. So this 5 will round that up to a 6. So the arc length should be 34.6 kilometers. Just remember your ratio of the small angle to the big should be in proportion to the ratio of the smaller arc to the circumference.